A lot of encryption fans in here this morning, so excited about that. You are in the right place. Welcome to Atlanta, if you haven't been welcomed yet. This is ActiveRecord Encryption, Stop Hackers from Reading Your Data. My name is Kylie Stradley. I'm a product security engineer at GitHub. I will have been working there for 2 years this May, and I am extremely excited to be presenting this morning with my teammate, Matt.
Hey everyone, I'm Matt. I've been at GitHub for just over 4 years now, and I'm super excited to talk about ActiveRecord encryption.
So you may have seen on the GitHub blog, we released a blog series about ActiveRecord encryption and our process of upgrading. And while we had a lot of fun writing it, we thought it would be maybe interesting to take a slightly different perspective for a conference talk, give people the opportunity to ask questions, and maybe kind of tell us about your experience implementing ActiveRecord encryption too. So here's what we'll talk about today. Why even encrypt database columns in the first place? What is ActiveRecord encryption? Why we migrated from our internal encryption strategy, how we store our keys, implementing a custom key provider, and then what I think is the most interesting part and is kind of maybe like the missing step is upgrading existing records. So we had previously encrypted records as well as most of the rest of the database is in plain text. And so we've kind of unlocked the ability for our developer teams to be able to convert plain text records to encrypted now and not have to feel like they have to plan that super far in advance. So you might have read or understand that GitHub encrypts our database at rest. Why do we encrypt individual database columns, and maybe why would you even want to do that either? Well, for a couple of reasons. Basically, it provides an additional layer of defense and depth against a hacker or a bad actor reading or tampering with your sensitive fields, whether that be someone who's gotten access to your server, they can directly access your database connection, or maybe somehow they've downloaded a copy of your database. It also prevents another security risk, accidentally exposing these values in logs, which is a much more fun and interesting problem to prevent than it is to clean up. And it's nice preventing this because you can actually schedule it and plan it out, whereas once you have to clean it up, you are now working on that right now until it is finished. So we recommend our strategy. Oh, sorry, one more note. You might be wondering what kinds of values would you even want to encrypt, right? Things like API keys, service tokens, secret tokens, or in some cases, email messages. So what is ActiveRecord encryption? It's a pretty classic Rails API. It's very, very easy to use, but also very opinionated. It provides encryption immediately on save and decryption on access. So here you can see we have an ActiveRecord class called personal access token. It's using that encrypts keyword to encrypt a database column called token. So now we'll talk a little bit about that existing encryption strategy that we had in place and why we chose to migrate to ActiveRecord encryption. So we had this really nice system in place when I first started working at GitHub. This implementation is pretty easy to use. Basically, developers just need to indicate the name of the database column where they want to store their encrypted value. So here that's called encrypted token. Then they need to indicate a name for their plaintext successor. So here that's called plaintext token. And it's a pretty easy access pattern. And if you have read about ActiveRecord encryption or you were looking at the last slide, you'll see it's actually a pretty similar API. So, I mean, great minds think alike, right? Yeah. And then we also had this other piece that was really, really important to us. And this was that we provided each column its own encryption key. And we created the name of the encryption key value from the name of the table, so personal access token, and you can see that reflected here in the name of our key. And it's also using the database column name, encrypted token. So we prefix with encrypted attribute, and you can see encrypted attribute, personal access token, encrypted token. And that's all stored in our secure vault, so keeping you, GitHub's customers, safe. And it seems like a pretty good system, right? Like fairly clean API, good access pattern, secure vault storage. Why would we even want to change away from this? We had a couple reasons, right? GitHub has a policy of staying as close to the standard Rails implementation as possible. So with ActiveRecord encryption released, our encryption code is now diverging from that standard. It presented the opportunity for a GitHub developer to try to use ActiveRecord encryption instead of our secured, hardened, paved path. And ActiveRecord encryption is very, very good, but as a product security team, we have a responsibility to vet any security tooling that engineers at GitHub use. And we hadn't vetted it yet. So we were thinking, what do we do, right? And this is kind of our workflow that we used when a developer team would reach out to us and say, hey, we want to encrypt a column. And maybe it doesn't look that arduous, right? Like there's only one decision point, there's like 4 steps in here. And we provided this information for the implementing developers to be able to generate their own encryption keys. But we found, unfortunately, implementing developers were more comfortable with our team generating and uploading the encryption keys to our secure vault. So this created a bottleneck where our team, other teams depended on our team to generate and upload the values for them. I do need to look at the speaker's notes, sorry. So this was a bottleneck, right? But as we were looking at ActiveRecord encryption, we noticed that ActiveRecord encryption's key provider pattern would allow us to effectively derive keys on demand at the time of writing code instead of what we were doing here, which is reactively generating and uploading the key. So initially, we would start with a team would come to us and say, hey, we're working on a new feature, we have a sensitive column, we think we may need to encrypt it. And we'd have this back and forth conversation. We would generate and upload the keys for them, but they couldn't really do much work without the key, right? This would let them have the conversation with us, leave that meeting, and then start encrypting on day 1. And then they didn't have to worry when they pushed to production, oh, are my keys present? Yeah, because your key's derived, it's already there. And I, like I'm sure many of you, also saw this Subway ad. Life is too short for generating encryption keys by hand, one by one. ActiveRecord encryption. I'm sure that's probably why many of you are here and why there are so many encryption fans in the audience this morning. Now Matt's gonna tell you a bit about how we store our keys.
Thank you, Kylie. So yeah, we at GitHub have a business requirement to store our keys in our secure vault. And so this means when we generate a key, we need to store it in the secure vault rather than the default encrypted YAML file for Rails. And we wanted to do this in a way that we can easily read these keys from Vault and during runtime without the developers needing to specify where to find the key in Vault. And so through this, we were able to create what was called a custom key provider. This custom key provider affords us the ability to not only read the key from Vault, but we can actually rotate the keys quite easily so that in the future, should there be key compromise or even just as good key hygiene, we can rotate the keys on a regular cadence. Lastly, like I said, so there is the default encrypted YAML file, but we can actually use what's called a custom key provider to read the keys from a location that we would rather read them from, like our secure vault. So Kylie's gonna talk a little bit about implementing a custom key provider.
Thank you, Matt. Yeah, so as Matt just explained and I mentioned before, the key provider pattern is really like what helped us remove the bottleneck from that workflow of getting teams from, hey, I think I have a column I need to encrypt, to being able to ship it to production. And so if you've read the ActiveRecord encryption guides, you might be wondering why we chose this strategy instead of some of the other customization options available. Why other than hubris, just unchecked pride, would we do all this and attempt to rewrite all of these parts of ActiveRecord encryption? Why not just use a custom key passed into the model, right? Surely we could just inject that key that I mentioned before we have stored in Vault into the custom key here. The ActiveRecord API lets you provide a key per model, but it's a manual intervention by the implementing developer, right? And that provides the opportunity to make mistakes. So sure, we could, enforce it with linting and things like that, but what if someone forgot to pass a key at all? Would it attempt to use the Rails default key? We'd have to write some more custom code to prevent that and throw an error. So we're already in a situation where we're gonna have to write some custom code, right? It's also a deviation from our service level goals. We decided at the very beginning of this project that the key generation was a bottleneck to developers, and we said developers shouldn't have to care about keys. It also provides a fun opportunity to use a weak key value for key generation. It may not be immediately obvious, but this key isn't actually the key that's going to be used to encrypt your records. This key is used to derive the key that's used to encrypt your records. It's generated, and that derived key is generated by the key generator class. And unfortunately, as you can see, Evil Clippy here is suggesting ways to bypass secure keying material. We will not be doing that. No, thank you. Goodbye, Evil Clippy. So now we're kind of at the stage of the custom key provider. Why did we choose to monkey patch it in, right? Conceivably, we could write a custom key provider and ask our developers to pass it into the encrypts method when they're adding a column that they'd like encrypted. So just passing a custom key for each column does not meet our standards, and while passing a custom key provider meets some of our requirements, it would still provide the opportunity for an implementing developer to incorrectly pass a key provider or make some other mistake. And we've already established that we do not want the implementing developers to care about the key, and that extends to key derivation as well. By monkey patching in the key provider, we bypass all of these concerns. So after a lot of deliberation, spiking, marathon pair programming sessions, including considering actually changing Rails encryption context to accept a single column at a time, we decided instead to monkey patch the encrypts method in our implementation. So this is a divergence from the ActiveRecord API, right? You can see that. You can now only encrypt one column at a time per encrypts method. But it made it much easier for us to do the other thing I'm most excited about, which is upgrade a single column at a time. Matt will explain that in more detail in a few more slides, but we have a bit more to learn before we can jump right into that. So we mentioned at the beginning we're product security engineers, right? As a product security team, one of our top priorities is making it difficult to make the insecure choice. We want making the secure choice to be the easiest decision you never have to make. So how do we reduce that risk in this pattern? By allowing only a single attribute to be encrypted per call to encrypts method, instantiating a new key provider for each column, unless of course a GitHub key provider is passed, and that's used for our upgrade pattern. And if you haven't noticed, the first half of this presentation is an advertisement for how cool the second half of the presentation is. These things snipped out aren't like super secret or anything like that. They're just not relevant right now. We'll get to this. Before we get to the cool part, which I feel like is the theme of my part of the presentation, I'd like to spend some time explaining how our key provider delivers the encryption and decryption keys. This current encryption key value you see here is actually the base keying material that we stored in Vault. Like I mentioned before, when you pass a key value that's used to derive the key, this is used to derive the key. We use HMAC key derivation function to derive a key for AES GCM 256 using this base keying material. Now, this is where it maybe gets a little interesting and you might think, hey, that doesn't look quite right. We decided we specifically wanted to use the table and column or attribute name as the salt to prevent accidental transposition of encrypted records. So you probably have heard of salting before, right? As something that you add to a secret value like a password before you store it in the database. In that context, you're adding random noise to a value so that you can only verify the value if you know the exact value, right? There's no, or hopefully, you never input your password in a form and they say, close but not quite, right? That would be very, very bad. So this salt is slightly different though. The secret value is the keying material, which will then be used to encrypt the actual sensitive data, the value that we store in the database. A value encrypted with a key salted this way can now only be decrypted by the same model that encrypted it, and this prevents transposition. You'll see here that we use the current year as a nonce exhaustion preventative. At GitHub scale, we're concerned about generating a duplicate nonce. This is called nonce exhaustion. Nonce exhaustion is the concept that if a nonce and a key are reused together, you'll produce two ciphertexts, which can be XORed to then reveal the XOR of two plain texts. ActiveRecord encryption uses AES GCM 256. This means Advanced Encryption Standard Galois Counter Mode. This means that the nonce is a special value that uses a counter to change the nonce on each use. Adding the current year here to key derivation adds an extra piece of slightly different value to the key once we derive it. So if you know encryption or cryptography, you'll notice this, but everyone else may not. Effectively, we have created a system that guarantees a new key is derived per column each year, greatly reducing the likelihood of nonce exhaustion. And now, another thing that's a little odd, you may also notice that we have a dummy key in our key material from the vault to create the key ID for our ActiveRecord encryption key. This is because we want to be able to use that vault stored keying material as the key ID when we rematerialize the decryption key. We derive the key when we encrypt, and then we have to rematerialize it to decrypt. So now we'll take a look at the delivery of the decryption key, and you'll start to see what we were laying the groundwork for in the encryption key. To decrypt, we basically just work backwards, right? We start with the encrypted message. We pull the key ID off of the encrypted message headers and use that value to look up the encryption keying material from our list of keys in Vault. That list of keys stored in Vault contains all the possible keying materials that could have been used to derive the key that was used to encrypt the record. Once we found the matching keying material, we can rematerialize the key from the anti-nonce exhaustion data stored in the message header, the key material from Vault, and then finally the salt of the table and column. So now that I've set the stage, Matt will show you how all of this supports our column encryption upgrade strategy and key rotation.
Thank you, Kylie. So yeah, I wanted to talk a little bit about upgrading existing records, specifically records that were encrypted with our previous encryption scheme, as well as records that were stored as plain text in the database. So first, I wanted to talk a little bit about defining a previous encryptor. ActiveRecord encrypts function allows you to pass this thing called previous. This previous is your previous encryption scheme, which will be used to decrypt the values using your previous encrypted attribute method. In this case, our monkey patch automatically passes this previous encryption scheme to the call to encrypts so that when developers need to decrypt previous records, they basically magically get it and don't have to do any additional work. Furthermore, when you pass a previous encrypt scheme, you can also pass a key provider to define which keys will be used for that encryption scheme. In our case, the previous encryptor had some logic to pull the keys from Vault, so we passed what we called a no-op key provider, which just passed no data for the encryption key. Lastly, I wanted to talk a little bit about how our previous encryption scheme will also read plain text data. So I'll jump into that in the next slide here. So defining to decrypt our previous encrypted attributes, what we had here is we called this GitHub previous encryptor. It's initialized with the table and the attribute name so that we're able to derive the key for our previous encryption scheme, in this case, GitHub's encrypted attribute. And once we're able to derive that key, we're able to decrypt the value that's passed. So when ActiveRecord encryption, the decryption part of that fails, it will fall back to our previous encryption scheme, as you can see here, which calls this decrypt function with the previous data. And that previous data is then decrypted using GitHub's encrypted attribute. And then it's returned as plain text to the application. So how do we read plain text records? Well, looking further into this decrypts function that we've defined in our GitHub previous decryptor, we're able to attempt to decrypt using the encrypted attribute. However, if that fails, we know that the data must be stored in the database as plain text, because by this point, it's attempted to decrypt using ActiveRecord encryption. That failed. It then fell back to trying to decrypt using our previous encrypted attribute, and that failed, so now it must be plain text. I wanted to also note that ActiveRecord encryption has a plain text mode, so that if decryption fails, it will fall back to reading plain text data automatically. However, we did not want to use this because that would activate plain text mode across all of our fields in the database that are using ActiveRecord encryption. And we didn't want that. Once we upgrade a plain text record to using the new ActiveRecord encryption, it should not fall back to plain text. So how does this all come together? Well, all of this allows for a very simple API for our developers. As you can see here, the personal access token, they're calling encrypts on token, and that's all the developer needs to do at GitHub. So to create a new encrypted attribute, they just add this encrypts field, and automatically they basically get decryption for free, they get encryption for free, and then if decryption fails, it falls back to either plain text mode or falls back to our previous encrypted mode. So basically, this means data from previous encryption schemes can all be read super simply just by one encrypts call. And so we made this API very simple for GitHub developers while also being super robust. So I wanted to touch lastly on transitioning data. How do we ensure that all of the data for a newly encrypted attribute is encrypted in the database? When a developer adds the encrypts flag, or sorry, the encrypts method to a token in one of their models, they're able to run this thing called a transition. At GitHub, we have what's called transitions. It's essentially a reusable migration. So it's similar to a Rails migration. However, it can be reused across different models. And in this case here, we're able to pass in a custom model and then iterate over all of the records. As you can see here, we call this like in batches function. So that's going to read all of the records from the database in batches. And then for each of those batches, we're able to call encrypts on the record. This record.encrypt function is part of the ActiveRecord Rails API or ActiveRecord Encryption API. And when it's called, it will take the data and read either the plain text data or read the previously encrypted data and then write it back using ActiveRecord encryption to the database. And actually in this case here, we had a little bit of additional logic so that if this were to fail, we would be able to roll back the transition. So just like an extra safety step should something go wrong while transitioning the data. And then lastly, yeah, so once this transition is run, all of the data in the database at that point would be encrypted. And then future data is automatically encrypted as well through calls to the ActiveRecord encrypts function. So that was basically how we upgrade existing data as well as upgrading like plain text and previously encrypted attributes. But I wanted to touch on a few other notable things that were important for us at GitHub. So the first thing I want to talk about here is using feature flags. At GitHub, we kind of had this race condition where rolling out ActiveRecord encryption could cause issues. So when we deploy at GitHub, we deploy to a subset of Canary servers and let that sit before we deploy to our full production environment. And so this creates the opportunity for a race condition where when we've deployed this ActiveRecord encryption to the Canary environment, it's possible for an encryption to occur there, write that to the database, and then when we attempt to read from the database, it would not read the encrypted value. Sorry, if we attempt to read from the database on the server that's deployed not to Canary, then it wouldn't be able to read that value. So we were able to get around this by using feature flags, essentially allowing for a safe rollout. When we deploy to GitHub, this feature flag would be disabled, and so no encryption would occur. And then once deployed to all of the servers, we could toggle this feature flag, which would happen instantly across all the servers. And so that would allow for encryption to occur. And the way we did this is we actually have a custom cast type. So Rails uses what's called cast types to serialize data to the database. And ActiveRecord encryption has an encrypted attribute type, which when the save occurs, that's where encryption would occur. So we wrote a custom cast type that overrides this ActiveRecord encryption cast type. And we can essentially use this cast type that we have to, when serializing to the database, determine if we should encrypt based on the feature flag. So what does this ActiveRecord encrypted attribute type look like? Well, our cast type here, sorry, it's a little bit complex, a lot of code on the screen, but basically we take some metadata, so some information about the table and the attribute that we want to encrypt, and then we have this serialize function, which is overriding the cast type serialize function. And so when the feature flag is enabled, we use what's called Flipper. It's just a library to check feature flags. But when that Flipper flag is enabled, then we're able to call the cast type, the parent cast type, which in this case would have been the attribute, the encrypted attribute cast type. We call serialize on that, and that's what writes the encrypted value to the database. However, if the feature flag was disabled, which is the case where we want to fall back to writing encrypted data, and so like this would be the case when we're halfway rolled out to some of our Canary servers, but not fully rolled out to production, then we can fall back to the previous encryption scheme. And to do this, we can first check, is the previous encryption scheme was it an encrypted attribute or was it plain text? And so we try and derive the previous encryption key, and if that key derivation fails, then we can fall back to plain text. And so this allows us, during a rollout, to safely deploy to all of the servers before we attempt to encrypt. Lastly, I want to mention too is, so when we fall back to this like plain text, we call the cast value.castValue.serialize, and so what that's essentially doing is the parent cast value in this case would be the encrypted attribute type, but then its parent cast value would be text. So by calling like one level further into the cast value, we basically say write this value as text to the write the value as text to the database rather than writing as the encrypted scheme. And then lastly, I wanted to touch a little bit about one other design feature that we had at GitHub. So by default, ActiveRecord encryption allows you to compress prior to encrypting. And there's a function in ActiveRecord encryption called compress if worth it, which basically checks if the string is over a certain length and then returns either true or false. And we did not want encryption to occur, or sorry, we did not want compression to occur. We definitely want encryption to occur. We did not want compression to occur before encryption for any of our data. There's a couple of reasons for this, but basically, we're storing high entropy data like keys or personal access tokens. And so this value already doesn't compress very well. But furthermore, it's generally bad practice to compress prior to encrypting, especially for our use case at GitHub. So maybe like if you're trying to store something like emails and you want that to be encrypted, then it would be more worth compressing. But in our case, we wanted to completely disable this. So we wrote this little compression patch that we can then prepend to ActiveRecord encryption that's able to ensure that we never compress any values prior to encrypting. Lastly, I wanted to mention that we're working on upstreaming this change as a configuration option to ActiveRecord encryption. However, we're not quite there yet.
Thanks, Matt. Yeah, so in summation, they say Rails is omakase, it's chef's choice, but we actually found ActiveRecord encryption to be very easy to customize for our existing code base and to adapt our patterns to. We felt that the custom key provider was a really good option for delivering your encryption keys, especially if you have a scenario like ours, like a business requirement where you must store encryption keys in something like a secure vault. And then we also recommend the previous encryptor strategy as a way to seamlessly upgrade your existing previously encrypted or plain text records. So if you're interested in any of the monkey patches that we talked about today, either to work on at your company or maybe you would like to help upstream them into Rails, we'd love to chat. And then if you haven't gotten enough ActiveRecord encryption, I mentioned the 2 blog posts that we wrote. You can find it this short link. And then we have another short link for the ActiveRecord encryption guide, which was very, very handy. And then finally, we are product security engineers. We are not cryptographers. So I found the book Real World Cryptography by David Wong to be extremely helpful in understanding some of the algorithms and like cryptographic standards and understanding the choices made there. Yeah, so thank you so much. This has been ActiveRecord encryption. Stop hackers from stealing your data. And now we have time for Q&A.
Yeah, I think we have about 15 minutes for question and answer.
I think the question was, what is the best practice for key size? And did we find if it affected performance? So AES GCM 256 by default uses 32 characters. Yeah, 32 byte key. So we just went with that because that's the standard. Effectively, AES GCM is a block cipher, so you get the same size value back out as you put in. So I don't think that key size would affect performance there.
Yeah, key size shouldn't really affect the performance there, but obviously like doing any kind of encryption will cause some performance detriment. But the performance trade-off here was definitely worth it for us. We had some stats and we noticed it was a little bit slower, but it wasn't so much slower that like the trade-off of encrypting the value was definitely more worth it. Yeah, I think it was, what's that? Oh yeah, sorry. So the question was, we basically did a lot of things to try and simplify the experience for our developers. And so do the developers actually appreciate the fact that we've done all this work to simplify it? And I would say that yes, developers had appreciated it. In fact, we had previously had this encrypted attribute scheme, but it was a very manual process that required developers to come to us. And so at that point, I think we had about maybe 5 columns that were using this encrypted attributes. But because it was so manual, there wasn't a lot of outreach and not a lot of developers really asking questions unless we maybe saw a column and told them about it. Furthermore, that required them coming to us to generate the keys. But by simplifying this process, we just did a blog post internally saying, hey, you can add this encrypts function to your column and then you get encryption for free. And so through that, we had a lot of developers adding this encrypts function to their columns, and we noticed we noticed a lot more columns were being encrypted. I think we went from 5 to 15 columns in the first week of doing this blog post. I don't know if there's anything you wanted to add to that, Kylie.
Honestly, just not having to generate the keys and upload them was developer happiness for me because I hate SSHing to the server ever. Every time I'm doing it, I'm like, oh, I shouldn't be doing that. Did you have a question? Right, so the question was asking if we were able to support deterministic encryption. So deterministic encryption would be basically, you can encrypt a value, but you can also use it for an index. And he mentioned an example of searching for things, maybe like phone numbers and email addresses. I am glad you asked this. I will say that this is, I'm not a cryptographer, but this is one of my strong opinions on encryption. I really don't think that if a value should be an index, that it should also be encrypted. Like if something really truly needs to be secret, then I just don't think it's a good candidate for an index, right? That value may change, who knows? So we disabled deterministic encryption at GitHub and we're not allowing our developers to use it. But I would like to talk to you afterwards about your use case.
I will mention, though, that ActiveRecord encryption does support deterministic encryption, but it's not something that we've really played around with, so I can't speak too much further to it. But furthermore, like the data that we are encrypting at GitHub is mostly tokens, so high entropy data, stuff that we wouldn't really need to search over. Yeah, so the question was, can we walk through what key rotation looks like? So as I mentioned, we had a business need to store keys in our secure vault. And so in this case here, we basically just store the keys as a semicolon delimited list in our vault. So right now, like if you have you have the one key and then you call encrypts, it will pull that key material. But when materializing the encryption key in our custom key provider, as Kylie had talked about, it will always pull the latest key. So to roll the key, we can just append to the semicolon delimited list. And then when encryptions occur, it will always use that latest key. Now, let's say we had one of our keys be compromised. We obviously don't want the previously encrypted data to be using that previous encryption key. So in the case of a key compromise, we can append a new encryption key to the key material in our vault. Obviously, like once we've secured the vault to make sure that there was no malicious access anymore. And so once we append this key, we can use that reusable transition I was talking about to encrypt all that data. It will iterate over all of the records and use the latest encryption key to re-encrypt the data. Once we've re-encrypted the data, if we really wanted to, we could remove that previous decryption key from that semicolon delimited list so that we guarantee that it's never used. So key rotation in our case, it kind of depends on the size of the column and the table that we want to re-encrypt. But basically, yeah, we append this key to this encryption list and then run the transition again. And basically at that point, it just depends on how long the transition is going to take before all the data is now encrypted with the new key. Yeah, so the question was, what factors do we use to determine if a column should be encrypted? When we first rolled out ActiveRecord encryption, we went for like the low-hanging fruit. So basically anything that was like a token that we could store in the database, like a personal access token, something that might get shoved into logs at places that we don't want it to. And so those were kind of like the low-hanging fruit that we were going after. And we actually wrote what we have. So we have an internal bot called Sentinel that will scan over pull requests internally. And so when a new column is added to the database, we just look for simple things like token or secret and leave a comment saying, hey, like you should probably encrypt this data. But honestly, anything that is kind of a token is usually an easy candidate for us. From there, we've kind of branched out and we wrote a blog post saying, hey, like if you think that your data should be encrypted, then maybe reach out to us. And so there's a way for teams to also kind of ask us. A lot of it is on a case-by-case basis, so it's not necessarily this column needs to be encrypted, but rather like we can have a little investigation as to like, should this column be encrypted? I don't know if there's anything you want to add to that.
Yeah, I think that covers it. Okay, so the question was, if you want to write a custom migration to encrypt a new column, is there anything special that you need to do? And actually, I think that we found that the answer was not really. There is an open source gem, and it is released by, am I on the, can you, oh, here we are. Yeah, there's a gem by Shopify called Maintenance Tasks, and it is, we have this internal thing called a transition, but Maintenance Tasks basically gives you all of that for free. And we found that if you set things up, all you need to do is call record.encrypt. You should basically never, ever, ever, ever called record.encrypt or record.decrypt in the course of just working with ActiveRecord encryption. And only when you're transitioning the data, I think that this is when you need to do it. But yeah, we found that this is really all you need to do, especially if you have your setup so that you can handle your previously unencrypted records or your previously encrypted records.
And yeah, with our transition here, we call object.constget, and you can pass it an argument. So in this case here, what that's going to do is actually going to give us our model so that we can use this transition for any model that we need to. And it's super easy for developers to just pass in the name of the model rather than having to write a transition for that model. And then realistically, all you need to do is just query over all of the records. So we have some like special logic at GitHub to perform this in batches so that it like throttles. And this way we're not like trying to access every record in the database at once. But yeah, just like some simple logic to iterate over all of the records in the model and then call record.encrypt. And this will work for any number of models that you have encryption on.
That is a very good question. Unfortunately, we're product security engineers, so we deliver tools to people who know how to solve that problem. Maybe they use index skipping? I don't know.
Yeah.
Sorry.
That's something that we haven't encountered yet at GitHub, but it's probably something that we will encounter in the future. And that brings up a good point, something that we have to do more investigation on.
So the question was, how much extra space would a previously plain text column take when we started to encrypt it? It was not a huge amount. Do you remember?
Yeah, so, well, we're using AES 256. So in that case here, it's like a block cipher. So 1 byte in equals 1 byte out when doing encryption. However, that's not like totally the case for active record encryption because there is some metadata that also gets stored. So we store like some active record encryption stores in a database as a JSON blob. Basically the header, the key ID, and a little bit of information about like the table and column that's being stored. And so there will be a little bit of overhead. I don't remember the exact overhead, but it was maybe like, it was a number of bytes, like nothing too crazy. There was a few cases where we had the column length wasn't large enough, so we needed to run a migration to extend the column length. But most cases, they could just add the encrypts and get it for free and not worry about the column length. So the question was, we talked a lot about the data that we encrypt, and so, sorry, was it like if we plan to roll this out for? Yeah. So in this case here, the question is like if we can store like or encrypt personal information as well, rather than just things like API tokens. At the beginning of rolling out this project, which was in November, we went for the low-hanging fruit, like the API tokens, as mentioned. But I think it is possible for us to encrypt more personal data. That hasn't really come up yet. Like we haven't really encountered too many columns that would require that. Again, it's a big thing that we didn't want was like leaking sensitive data in logs. And so these API tokens and personal access tokens are pretty sensitive and we don't want that in the logs. However, it definitely is possible for us to encrypt anything that we don't need to search over on an index.
So the question is, sometimes developers want to use like a secret token as a lookup value. Yeah, we've disabled deterministic encryption at GitHub, so we're just not allowing it.
We also haven't encountered that use case yet, so it might be something we'll need to reevaluate down the road, but as it stands right now, it wouldn't be possible. Cool. Well, hopefully you all learned something today and enjoyed the talk. Thank you.
Thank you.